To begin, let us acknowledge that Queen's University is situated on traditional Anishinaabe and Haudenosaunee territory. We are grateful to be able to live, learn, and play on these lands. We thank the Indigenous peoples of this area for their care of this land for thousands of years, and we hope to honor and respect them as we hold a virtual event today. I'd also like to take a moment to thank everyone personally for joining our presentation today. Our speaker this afternoon is Dr. Mohammed Morshed, who will be presenting on passive tick surveillance in BC. What have we learned so far? Dr. Morshed is a public health clinical microbiologist at the British Columbia Centre for Disease Control Public Health Laboratory, where he's serving as head of the Zoonotic and Emerging Pathogens section. He is also a clinical professor in the Department of Pathology and Laboratory Medicine at the University of British Columbia. Dr. Morshed is internationally known for his expertise in vector-borne and zoonotic disease research. His area of interest is spirochetal disease, such as Lyme disease and syphilis. His laboratory is engaged in tick surveillance and tick-borne disease since 1997. Dr. Morshed has added significantly to the general knowledge and understanding of these diseases with more than 130 refereed scientific publications. He received an Excellence in Clinical Services Award from the UBC Department of Pathology and Laboratory Medicine in 2016, was named a winner in the RBC Top 25 Canadian Immigrant Awards in 2017, received the Distinguished Microbiologist Award from the Canadian College of Microbiologists in 2018, and became elected as an expatriate fellow by the Bangladesh Academy of Sciences in 2020. We will have Dr. Morshed present, and then we will open for questions from the audience. You can ask your questions by entering in the chat box or raising your hand using the icon, or when the opportunity arises, unmuting and asking your questions. Please help us welcome Dr. Morshed to the podium.
Thank you. Thank you, Veronica, for your nice and kind introduction, and hope everyone is listening okay. And I'll try to share my screen. So which one is this thing? This one. Can you see the slide now?
I can, but can you go to display setting at the top and switch the view?
Yeah, display setting.
To swap presenter, yeah, the first one.
Yeah, so you can see now, right?
Just give it a click with your mouse. It seems to have not activated.
Just, I don't know, maybe I have to do it one more time.
Okay.
Now share the screen. Share. How about now?
We can see.
Is it okay now? Can you see now, Veronica? See the problem.
Morshed, you're in the view that, hi, by the way, it's in the, you need to go display settings and click on the top one. There you go, perfect.
Okay, thank you.
Thank you.
Sorry, but I always have these technical difficulties. I don't know why. Whenever I try to fly, that always I get the notice that said technical difficulties, 30-minute delay. And whenever I want to present, there's some technical difficulties as well. So thank you very much for your nice introduction. And today I'll talk about the passive tick surveillance in BC. And as I mentioned, what we learned so far. So I'll start with this slide that, as you all know, this climate change is upon us, and because of this increased level of CO2, rising temperature, rising sea level, increasing extreme weather event, there are lots of things happening. And one of the thing is vector distribution and ecology. And we are seeing changes. We are seeing that tick population is increasing, mosquito population is increasing, all the other vector-borne diseases is kind of mauling all over the globe, and COVID, and then now H5N1, and all sorts of things are happening. So I'll start with this slide. So I don't know that any of you in this audience know about this meeting happened in 1963 in Kamloops, British Columbia. This meeting was called that International Northwest Conference on Diseases Communicable to Man, but then it was changed name few times. But that time that there was a center in Kamloops, they were very much interested in tick-borne, flea-borne, mosquito-borne diseases. And these are the proceedings and the front page showing that in Kamloops area or Okanagan area, that what kind of insect are predominant and which area. So that was a kind of neat map. So BC, what I wanted to say, that BC has a long history of surveillance on vector-borne and zoonotic elements. All of you know, but as a kind of 101, and the tick-borne diseases in Canada, there are so many: Lyme disease, relapsing fever, tularemia, Rocky Mountain spotted fever, anaplasma, Poisson, Colorado tick fever, babesia, tick paralysis, and now we know that there is also some other rickettsial diseases that we have seen in our group, that rickettsia, new rickettsial species we found. So there are many other things like Miyamoto is a new one that we are seeing now, and the babesia, not only babesia microtis, some other thing we are seeing now. So there's so many of tick-borne diseases alone, apart from mosquito and flea and other thing. And Lyme disease in BC is from the beginning, when that Lyme bacteria was discovered in Connecticut back in 80s. And you can see some of those publications in 1990, 1989, and 1998. So the early 90s that BC started doing lots of tick related study, and then there's no shortage of news. So BC was on the game from the beginning when the Lyme disease has been discovered. So for today's presentation, that although the title says that the passive tick surveillance, but what I'll do to give you a kind of a whole story, I'll talk about some active surveillance by trapping mice and collected ticks by dragging, and then from the trapped mice that we retrieve ticks from the trapped mice. So I'll show you some data on those. And then also in BC, not in BC, I can claim that in North America, the BC did the first findings of Lyme disease positive ticks on passerine birds. So we'll talk about some tick surveillance in passerine birds. And then the last but not the least, I'll talk about the passive surveillance by receiving ticks from different sources. And different sources mean that from at the beginning, the public was a huge resources for us. Everybody wholeheartedly submitted ticks, veterinarian, physician, entomologist, anybody, they found ticks, they submitted to BC for passive surveillance. As a methodology, as you know, that is not that fancy, but this methodology working since that tick or any insect study entomologists are doing for sample collection. For tick collection from the environment, there's two different ways that we do. One is called dragging the piece of white cloth with the left-hand side, you can see. And then another one that we use the small trap to trap some small mammals like the deer mice or small squirrel and other thing. And then we bring them to the lab, and then we kind of check on their body and find ticks on them. So this is the both type of methodology we use throughout our surveillance study. So this is our active studies that now I would like to show you. So you can see that A, B, C, D. So A is the kind of the land cover type. So as you all know that Lyme disease ticks found more in bushy forest or leafy forest rather than pine forest, and BC has lots of pine forest area. So we choose areas those have more leafy forest. And then B also we have done in our center that predictive modeling. So based on that, we know that which areas are suitable for Lyme disease. And this combination of these two, we selected 12 different sites, and the C and D, you can see that where we found the mice, and then what are the location that we studied. So we went to like the Lower Mainland, Vancouver Island, and some interior sites. And we, so sorry, yeah. So now this another study, that the bird study that we have done. So first, isolation of Lyme disease spirochete Borrelia burgdorferi from black-legged tick Exotis capillaris removed from a bird in Nova Scotia, Canada. So that study was done in conjunction with the Lyme Society of Ontario. They kind of help us to get the ticks from the passerine birds, and in our lab that we cultured the spirochete and characterized them. And this was the first publication, came in year 2000. And this is the North American first study found out positive Lyme disease carrying ticks in passerine birds. And after that, with the same group, the Ontario Lyme Disease Society group, that we contacted different bird banders in BC. So like the Wilson Creek, Westham Island, Victoria, Rocky Point, Courtney, Marville, and then Queen Charlotte Island, and then few other areas in that island, the West Skidans, East Limestone, Lower Island, Reef Island. And we in fact found Exotis auriculus, Exotis muris, and then also we found in the same place that auriculus and Exotis pacificus. So this is also another piece of work that BC has done in conjunction with Ontario Lyme Disease Society. So now later that you can see that across Canada, many places, different groups, they have done work, and they have found again the same, the Lyme disease bacteria in passerine birds. So now we know that how the tick could move from place to place and settle there, and then they can carry the positive ticks, so they can make the new population and with this climate change. So now I will talk about the tick surveillance in BC that started since 1993. So I was not there. I started at BC CDC in 1997. And before that, Dr. Banerjee and Dr. John Angus Smith was the lab director at that time, started working on collecting sample from different places. And these are the many locations over the 24-25 years time that we've been to and looked for the ticks either passively or actively. So over 200 different places we've been so far. So from 1993 to 1996, which I was not here at that time, Dr. Banerjee and Dr. Smith, under their leadership, they collected over 10,000 ticks, and they found about 40 positives, about 0.4%. And in mice population, there's a very few mice they collected. The few mice they got positive, but they collected about almost more than 2,700 deer mice, and about 0.9%. So you can see that mice was more positive than ticks, but none of those are more than 1%. And at that time, all of those were cultured. No, PCR was not available at that time. So after I joined, so I started working on the same project. And then from 1997 to 2007, when we did the culture, we collected about 8,600 ticks, and we found about quite a few positive in mice and ticks. And you can see that mice, only few mice that we collected, unfortunately, during those time, but the ticks we collected humongous amount and found 0.35% ticks are positive and 0.6% mice are positive. But having said that, at that time, we only cultured Exotis pacificus ticks when I started, but prior to me, they collected both Exotis pacificus and Dermacentor andersonii both, and they cultured tons, thousands and thousands of Dermacentor andersonii, and none of them become positive. So, and then literature also suggested from the laboratory-based experiment that Dermacentor andersonii is not a competent vector. So I deleted culturing Dermacentor andersonii based on that humongous amount of data as well as the research study to save some costing. So now what I'll present that the passive surveillance data from 2002 to 2021, but I think there's 2019 data is missing, but I'll show at the end of the slide some 2019 data as well. So there's active surveillance we have done, as I mentioned already, in 2004, 5, and 7 through the Climate Change Action Fund, and from 2013 to 2014 from BCCDC Foundation funding. So we, from 2002, we try to get kind of more scientific way of surveillance rather than initially we started at random. So here we try to collect some information like the year, month, collection date, and the host species and tick. We identified up to the species and stages. And also we try to find out the location, province, and other, and then test results of the Lyme disease test results. So all together, you can see that in human, passively, we collected about 10,000 ticks. And animal, we collected active about 658 from those few field studies and over 5,000 from the passive surveillance. So total that 658 active surveillance ticks and the 15,634. So altogether, over 16,000 ticks data that we'll present today. So now animal host, what are the animals that we found ticks from? So you can see the list on the left-hand side where they put the animals. So that there's a deer mouse are the most prominent, and then Western harvest mouse, pocket mouse, chipmunk, shrew, squirrel, and then obviously that some pet like cat, dog, rabbit, bird, pigeon, cow, bovine, elk, horse, moose, all sorts of animal we got either through active or through passive surveillance. So then we try to take the tick ID breakdown from the active and the passive surveillance. So you can see that the major tick genus in our study from this 20 years period was mostly Exodus and Dermacentor. And then also we found Rhizocephalus, amblyomma, and then ornithodors. Ornithodors is a soft tick that is not related to Lyme, but we keep because it was surveillance, we keep into the database because it is mostly Ornithodors hermesii, which is carrying Borrelia hermesii, cause relapsing fever pathogen. And in BC, in the interior BC, like Summerland, Okanagan, that zone, we have seen many relapsing fever cases every year. And then also we found Hyaloma, Hemophysalis, Ortobius, and all together those tick species as I mentioned before. So now what are the species we found? Previously we showed you the genus. So amblyomma we found Americanum, maculatum, cagenesis, and imitator. And the Dermacentor we found Andersonii, Albopictus variabilis, and occidentalis. Hemophysalis we found Leprospolosteris and another species, we don't know what that is. And then Hyaloma also we found the marginatum plus species that we couldn't identify. Exodus we got enormous amount of species because that you know that BC has the highest and the diversity of Exodus ticks. So Pacificus angustus, Orizola, Scapularis, Ricinus, Sorisus, Texanus, Cookii, Holocyclus, Daminii, Harleyi, Exogenous, Jellisoni, Kingi, and many. But having said that, because it's a passive surveillance, the people submitted ticks. So as for example, somebody went to England or Germany or Russia, and they brought back ticks. So some of those exotic ticks are there as well. So not all of them from BC, by the way. Ornithodors, the soft tick that we got Hermesii, as I mentioned before. Ortobius, we got Magnani, and Rhizocephalus, we got Sanguinus. So these are the different species that we found in BC over the 20 years period. So now what are the different stages? As you can see that the striking difference between active and passive surveillance, the passive, we found mostly passive surveillance that the female adults are the most, and then male also we found a nymph. We found more in active surveillance when we compare that. About 658, we found 190 nymphs with the active surveillance, and with the 15,000 ticks, we only got 635 through passive surveillance. And the larvae also we found active surveillance, but we didn't get any larvae through passive surveillance. That means that is so tiny that people doesn't realize that they have been beaten, and ultimately the people might get disease by that way as well. And then sorry, so larvae we found 45, sorry, yeah, 45, but you can see that within 15,000 ticks, we only got 45, but we got lots when we did the active surveillance. But this 45 also, many of them that came with the female ticks. So we don't know that it's just they may be hatched at the same times when they are kind of keeping in their house. I don't know. So that could be as well. And also that some people, they really looked carefully to their pets. So we found many from cats and dogs as well. So now I'll show you some data from 2002 to 2018. You can see that the animal human ratio from 2002 to 2013 was almost same, like the 50-50 ratio of animal and human submission. But 2014, you can see that the animal submission dropped significantly. And there is a reason behind it. But at the same time that from the human population, the tick submission went up. The reason being that because of the financial issue that our operation team, the BCCDC Public Health Lab operation team decided that they will only do free of cost tick identification and Lyme disease PCR only for human, but we will provide the service for veterinary population, but they have to pay for it. So there are some financial implications. So that's why the number went significantly down from that one, from 2024. And still the number is really, really low, but that we can see that from 2013, the number of tick submission from human is going upward. So now we'll show you the seasonality. You can see that I'll show you the line graph, so that will be much more visible, but you can see from the January to December from 2002 to 18. So April, May is the highest number, April, May, June, and it start from March. So March, April, May, June are the kind of main timing to see the highest number of ticks. And then we see a little bit blip onto the another like October, November, around that area. But I think that these are the much better picture. You can see that it started kind of going up, like Exotis specificus from January, showing that when we aggregated the figure, and the Dermacentor andersoni, the peak started from March and goes down in July, and all other species, they are all over the place. But the I pacificus, somehow, although the peak time was March, April, May, and June, but it start increasing in January. And that we found that, by the way, most of the tick start pouring from January from the island faster than from the mainland. And this is another slide on the seasonality. So it's clearly showing that March to June is the highest number we see. And you can see that October, November is a kind of little slight blip. And this is much more clearer. So you can see that Exotis, that October to December, there's a small blip. But again, this the bigger peak you can find in the March, April, May, June time. So the test result that we found around that all those over 16,000 ticks in active surveillance, we found 6 Borrelia positive, and the passive surveillance we got 32. But for Miyamoto eye also we got 2 positive. So one from Nanaimo, one from Vancouver. So now these positive ticks, when we break down with the species, we found like more from Angustus and Pacificus. The Pacificus, of course, most, because the Pacificus submission was also the highest. And then also that we found some Ricicibilus sanguinus, we found one from passive surveillance. So this is also, I think you will not find in many places. They found Borrelia burgdorferi ticks in Ricicibilus sanguinus. And then we got scapularis, they may be travel related, came from the east. And the Pacificus, of course, we got from both animal and human. And Auriculus we got from animals. And Auriculus is a bird tick. It's usually avian ticks, but somehow it landed on the animal. And then we also got significant amount of Angustus, depending on the submission, positive from the animals and human as well. So now, what are the tick carrying host, the positive ticks carrying host? So we found out that animal like the deer mouse, the most with the active surveillance, and Western harvest mouse we found one, and with the passive surveillance we found the bird about 4 and the cat 3, but most of the positive we got from dog. And as you know, that dog, who is in the owner, take them for leasing, and they went to the forest and they kind of released lots of CO2, and the CO2 attracted the dog, the ticks to the dog. So that's why they get more ticks compared to any other animal. And that's why maybe they get more positive, because they get more exposed to ticks. When they go inside the forest, they bring lots of ticks. And human also, we got 7 positive, squirrel we got 2, and the total 34, and the grand total from the 6 from active surveillance and 34 from the passive surveillance, altogether 40 positives. So now, again, this is the kind of pie chart. You can see the most, again, to show the kind of the figurative visible figure. That's 47% we found in dogs, 20% in humans, 6% is squirrel, other animals 6%, bird 12%, cat 9%. And then again, if we see the percentage, again, you can see the dog are the most, the point, although the 0.37%, but the cat is kind of, again, depending, this is kind of misleading in a way, because you can see that Western mouse harvest is 7.6, but we collected very few, and bird we collected very few, that's why 6%, but it doesn't mean that they carry more Borrelia. As for example, squirrel, we got only 2 or 3, and then we found positive, so that's why 66%. So this is kind of misleading slide, but I just wanted to show you in a percentage. So now, tick density by the location, which location we found most of the ticks. So you can see that Victoria has the highest number through passive surveillance, and then followed by Lower Mainland, in Vancouver, and the Kelowna, North Van, Squamish, Kamloops, Seychelles, and the Coast Garibaldi, Surrey, Nanaimo, Hope, and West Vancouver. So having said that, we are also seeing more positive Lyme disease bacteria from Victoria, from the island, so which I'll show you later. So now, positive tick location, that if you see that yearly breakdown, so these are the many areas that we found positive from. So you can see that the North Van, we have the highest number, and also from the Vancouver, and the Victoria is the 8, as I mentioned, that they have lots of positive and lots of ticks also coming from that area and the Vancouver area. And the North Vancouver is always we found ticks from there, but all other places are kind of very low compared to the positive number, and then the number of span that we did the surveillance study. And then this location wise, you can see that our active and passive surveillance both are concentrated heavily on Lower Mainland and Vancouver Island. This is the Lower Mainland, and this is Vancouver Island. But we have done in some distance areas like Smithers and kind of in Kelowna and Summerland, those areas as well. So, but mostly lower mainland and Vancouver Island. And on the right side, I put some active surveillance and passive surveillance. Passive is the kind of bluish, and the active are the pink one. And you can see these are the areas that we did the surveillance study mostly. So now, again, that you saw from the table, but I wanted to show you from the pie chart the tick composition in BC from 2002 to 2018. Exodus are the highest number, and then Dharma Center. The Exodus is 66.31, and the Dharma Center, and then remaining are very, very, very few. And but if you see this picture, you will see that in BC, Exodus is the highest number we see, 66%. But again, tick is kind of geographically is very specific, and that their distribution is very unique. So if you see this one in interior BC, almost over 90% are Dharma Center, and most of them are Dharma Center and Andersonia, but they also have some Exodus and some other species, but Dharma Center are the dominant species in interior BC. So now then I'll show you some data. As I said, the 2019 is missing. So we did analyze the 2020 and 2021 to give some update in our groups. I thought I'll show you that what is happening there. So again, in terms of species, we saw many species, and we saw also that a total of 1,400 ticks in 2020 and 1,200 in 2021, and then this is the grand total. And that again we are not showing positive, but again there's Ornithodoros hermesii, there's only one. This is Sipulus, and many Exodus species, many Dharma Center species, and Embryoma species. So now positive. So this is very interesting. You have seen in the previous slide that most year we found either 1 or 2 or 3 positives. So that's why I think this slide is extremely important. So you can see that 2020 we got only 2 positive, but 2021 we got 7 positives, and the 5 from the island and 2 from kind of Fraser Valley. So 1 from Hope, 1 from Port Moody. So you can see the 7 of them in a single year. This is the highest yield of passive surveillance in my 25 years of practice at BCCDC Public Health Lab. So this is not an anecdote. I feel that because of the climate change and because of the other elements, I think that the positivity is increasing, and then now more positive pools are happening around the Vancouver Island area. So we might see more cases of Lyme disease from Vancouver Island area. So that is my prediction. So now, but again, that this is the kind of, we are seeing that after 24 years of study, we are now started to seeing some blip. So that means that what are the value of surveillance that in a year or 2 or 3 or 4 or 5, you might not see any changes. But if you continue, then it is kind of fire office that you never know when the fire will start. And nobody wants fire, but it will happen eventually. But then it will be unnoticed if you do not have fire office or if you do not have surveillance system. So if we would not have continued the surveillance, we would not know that Vancouver Island would have that many positive in a single year. But again, still in terms of the population, in terms of the 5 million population, the number is minuscule. So I'll show you some, it's not us, it's all Pacific West Coast is the same thing. So what I did, I picked up some data from CDC USA, and I took some older data like 2009, 10, 11, 12. You can see BC, our rate is 0.2, 0.2, 0.4, 0.4, and 2019, 0.2. Washington also, you can see all through 0.2% incidence. Oregon 0.3, 1.1 to 0.3. Idaho, all are below 0.5%. California even 0.2. On the other hand, the total US is more than 7%. So you can see that certain areas like Vermont or like Massachusetts or New York, Connecticut, Rhode Island, they see 40-50%, 40 to 50 cases per 100,000. But we are seeing 0.2 cases per 100,000 in BC. So that's why I think that the surveillance study that we do and the diagnostic work we do, this is kind of another quality assurance or quality control that we are seeing, that we somebody might thought that we are missing the cases, but we are not, because our surveillance data is also matching with the diagnostic data from the human. So now, as you know, that the beginning slide that I showed you, that we are doing lots of surveillance work, but that I showed you the slide 2 or 3rd slide, I can remember now, I showed you that how many different pathogen ticks can carry. And so far, we are only doing that Lyme disease bacteria, Borrelia burgdorferi PCR, if the tick is exotis. But is that enough? So we thought that we should do some enhanced surveillance. So now what we are doing the Borrelia species, mean that it's not only Borrelia burgdorferi, we'll be getting Borrelia miyamotoi or any other species that is Borrelia genus will be positive. And if it is negative by Borrelia burgdorferi, then we have a collaboration with our National Microbiology Lab partner, Dr. Robin Lindsay and his team. We send the extracting material to him, and then he kindly do the rest of the work for us and tell us that whether it is miyamotoi or it is other Borrelia species. And then we also, for each run, we also do that internal positive control, and then also we do the hemoglobin gene as well for human. And then we have another 2 sets, and one is testing for Ehrlichia and Anaplasma, and another is testing for Rickettsia and Babesia. So all together now we have a capacity that we can diagnose 5 different pathogens. It's not all. You have seen that there were 10 or 11, but we can at least do half of them. So this is, we have just completed our evaluation, and we started doing this, the multiple like multiplex PCR to identify Borrelia, Ehrlichia, Anaplasma, Babesia, and Rickettsia from our tick species that we received from the BC human as well as from the animal population. So now that this enhanced surveillance is covering Borrelia, Ehrlichia, as I said that, and also the recently we added another one, Rickettsia. So we are slowly trying to increase our capacity. That is what I want to share with you today. So now what is new happening in BC? As you know that we also started ETIC program that Dr. Erin Fraser, she's a veterinary physician, veterinary doctors at BCCDC Public Health area, and myself included, that we started this ETIC program. So what it means that we wanted to capture certain area that we are seeing the low submission, as for example, from the far distance of the BC, because BC is quite big, and from Meritz or Port Hardy or some areas, they don't bother submitting ticks. So that ETIC program, I think many of you know that, so if they find a ticks, they will take a picture with their cell phone and send it to that ETIC program. And then we have an entomologist, she will identify if it is Exotis pacificus, then the client will be told to keep the tick in their freezer for a few days. And if patient becomes symptomatic, we'll ask them to submit ticks to us. And if not, they can throw them out. And if it is Dharma Center, then they'll be told them to throw them out. So this is the way, hopefully, we'll be getting more ticks from the areas that we are not seeing right now. And we have done already few months, and then that one of our colleague, Stefan, he presented the data, and it looks like it's very promising. The areas that we never saw ticks, now we are seeing many ticks through this ETIC program. Another one that Dr. Patrick Layton is leading, our Canadian Lyme Disease Research Network active surveillance program. And through that program across Canada, from coast to coast, from Newfoundland to BC, that there are many spots that he and his team is collecting, and I'm also included in that team. And BC, we have selected initially about 5 spots. Now we are selecting more spot. So we are doing that for last 2 years, I guess. And it will be, maybe if Patrick is here, maybe he can add a little bit more after my talk. So that program is also showing is a very good progress. And last but not the least is today that my friend Robin Lindsay kindly forwarded this email I saw this morning. So CCDR just published the Exotic Pacificus and Exotic Specularis tick submitted through passive tick surveillance in Canada. So this is the dream I had when I started in 1997, that I always wanted to see a picture like CDC showed that all states, that what ticks are available, what are the highest endemic area, high density ticks area. And this figure was missing for last 24 years. So this is the first time this morning I saw this paper, so I thought I'll share with you guys. So you can see now from coast to coast, the tick density we found, so that people can easily be cautious to going those areas and check themselves at the end of their outdoor activities. So you can see that Exotic Pacificus kind of brown, and the dark brown is Scapularis. You can see that in BC solely Exotic Pacificus, but Alberta I can see there is a place where the mixture of Exotic Pacificus and Scapularis. And from onward, Saskatchewan onward up to the Newfoundland, Labrador, so all are Exotic Scapularis. And as you all know, Exotic Scapularis carry more Borrelia burgdorferi compared to Exotic Pacificus, because from the research, from the practice, from the surveillance data, we know that Exotic Pacificus carry much less Borrelia burgdorferi compared to Exotic Scapularis. So as a conclusion, I'll say that BC has a robust tick surveillance system in place. This is compared spelling mistake, compared to many parts of Canada, as well as in North America. Many North American state doesn't have the robust surveillance capacity like BC, and both active and passive surveillance data support presence of B. burgdorferi, but positivity rate, as you have seen, remains low. But again, so some data that we are seeing from island is alarming. Tick carrying Lyme disease causing spirochete in BC is low compared to the high endemic eastern states, which I mentioned, like New York and Connecticut and Rhode Island, all those places. If you test 100 ticks, 60, 70 will get positive. But if you test 100 ticks in BC, you might not get any positive unless you test 300 ticks, then you might get 1 positive. And healthcare professional and resident need to be reminded about the different aspects of Lyme disease, including preventative measures. So I'll stop there, and I'll be happy to answer if anybody has any question.
Thank you so much, Dr. Morshed, for your presentation. I will go to the chat box and see. I don't see any questions in the chat box, but if anybody has a question for Dr. Morshed, please raise your hand icon or unmute and please ask your question. We do have some time. I have a question from Emily Jenkins. Please go ahead, Emily.
Hello, and thank you for a great talk, Dr. Morshed. I have the privilege to teach the BC vet students about parasitology, and so this is really, really helpful for me to give them a perspective. I just wondered how much the overall BC proportion between Ixodes and Dermacentor, is that biased by a disproportionate emphasis on submissions from the coastal region and the island? Because I think there is a perception even amongst practitioners that there's a lot more Ixodes pacificus in the interior than there actually is looking at your data.
I totally agree with you. And the submission that we cannot control, that whoever is submitting, that we have to test it them. And I kind of showed you that anterior submission over 90% are derma center. And that could be two different reasons. One reason could be the derma center is quite larger in size compared to the exotic specificus, especially in the nymphal stage, and people might not even notice and they don't submit. And number two could be that they don't bother. And I can say that there are more exotic, but my inclination that rather than exotic specificus in the anterior, we might see more exotic angustus, because I did in 1997 or 1998, we did some, we went there to collect some soft tick exotis, the Ornithodorus hermesii, and we spent 3-4 nights, and we did some nocturnal sampling and everything. But other than finding that Ornithodorus hermesii, we kind of trapped deer mice, and from the deer mice we got quite a bit of exotis angustus rather than exotis specificus, and they also carry Borrelia burgdorferi bacteria. So that's why I think that if I think that this ETIC program, because now this is more less cumbersome, because they only have to take the picture and send it to the group. And nowadays, especially the younger group, they are more technologically savvy than my generation. So we are already seeing some advantage of ETIC. So I'm hopeful that with the ETIC program, we'll be able to answer that question. So whether we are biased or not biased, I think that will be helpful, I think.
No, that's great. Thank you. And one last question, if I might, paralysis. I know
Yes.
D'Andersoni is a paralysis tick.
Yeah,
I had heard conflicting reports on Ixodes pacificus. Can you weigh in on that argument?
Yeah, so that's an excellent question. Yes. So what I have done, because the tick paralysis that we get, at least half a dozen to a dozen tick paralysis case, because when we get the Dermacentor Andersoni, they wrote the tick paralysis. When they get exotic specificus, they wrote exotic tick paralysis. So what I have done, I collated about 10-20 years of data, and then when we put the data together, and interestingly, it's not Dermacentor Andersoni alone. We found tick paralysis by exotic specificus, by angustus. So I think that you can see that publication. I think we published in most likely Vectorbone Journal or BCMJ, I forgot, but I can forward that to you. So that we have demonstrated that exotic specificus and other exotics can also cause tick paralysis.
Great. Thank you so much. I'll let Patrick jump in now.
Thank you, Dr. Jenkins, for your question. And go ahead, Dr. Layton.
Hi, Dr. Morshed. Thanks a lot for that great presentation. The 30 years of surveillance data pulled all together for us to look at. That was really valuable. I just want to get your overall sense when you're looking at the human case data, the active tick surveillance, passive tick surveillance, and rodent surveillance and all together. And you're mentioning that you feel like there's something that's changing now that you haven't seen in a long time. And then also it seems to me that there seems to be a stronger signal maybe from Vancouver Island, either than there was or in the recent past. Do you have a sense that something different is happening in terms of the ecology on Vancouver Island versus the mainland? Is there a shift there, or are things increasing everywhere in coastal BC sort of equally?
Yeah, I think that I would say that Vancouver Island, I'm seeing, I don't know, I might be biased because I'm seeing that when I see the cases, and I see not only for Lyme disease, for any other vector-borne diseases. For example, there's a snowshoe hair virus and California serogroup. I'm seeing more from the island and then also the ticks. We are seeing them. I have never seen 7 positive in a ER from the island. It never happened in last 24 years. And we are getting same number of ticks almost. So although the human, as I showed that, because that we are not, we are charging for the veterinary population, so we are getting more human ticks now. So I don't know, they're getting in their dogs and sending with their name. I have no idea, but at least the tick number are increasing. So, and I don't think they're doing that because that they have to submit through their physician. So there are double checks. So I think the tick number is maybe increasing. And with your data, Patrick, that I have never seen the tick by dragging. But when Camille came first time, she found first time by dragging exotic specific sticks. So definitely the tick number maybe started increasing somehow. That is my kind of feeling. But the time will tell. Another 5 years data might either support this or deny the findings that we had in 2020. So yeah, I think that this will be an interesting time, and then the weather is also dramatically changed, and now we're getting more heat and more cold. So I don't know that what will come in another 2 to 3 years. I think that your project will give us huge amount of information. That is what I'm looking forward.
Great, thanks. So definitely something to keep an eye on in BC.
Thank you, Dr. Layton, for your question. We do have time for 1 or 2 additional questions if anybody has any questions for Dr. Morshed. While we're waiting for someone to raise their hand, Dr. Morshed, I know when Dr. Gregson presented, I guess it would be last week on the tick in humans in Alberta. And I think with similar question was asked about, with the pandemic and COVID and with the borders being closed and restricted for the first part and more people moving out. Did you notice any changes and increase in ticks, particularly in humans or on animals, or was it pretty much static and the same?
Yeah, it was pretty much static. But having said that, so if you do a kind of regressional analysis, you can see that even with the restriction, that 2020 and 2021, what we all went through. Nobody even dared to went out from their house. Even then, the tick number got increased in human population. What does it mean? If it would be normal time, maybe we would have seen more ticks. People have gone more outings, because I know the Lower Mandan, very few people went for camping and anything for that particular year. Very few did. So even then we got that number of ticks. So that's why I think that my gut feelings that yes, I think he was right, that pandemic did prevent, but still we got significant number of submissions.
Thank you. One last call. Does anybody have any additional questions for Dr. Morshed? Checking the chat box. Don't see anything. Okay, well, I do want to thank Dr. Morshed for presenting today on his data from BC, and hopefully we'll get him back again next year with an update of where things are. I do want to let everybody know that we are continuing our series tomorrow. We have Dr. Elizabeth Stringer, who will be talking about pediatric Lyme arthritis, the next wave of Lyme disease in children. So hopefully we'll catch you tomorrow at 1 p.m. Eastern Standard Time. And also a reminder that please take part in our challenge, wear green or wear a green face mask, take a photo and share it with us to help spread awareness of Lyme disease. You can also be artistic and send in drawings. All entries received will be automatically entered into one of 4 $25 Starbucks e-gift cards. And our live draw will occur on the day of our last presentation on May 31st. You can send your entries to clydern@gmail.com. Again, thank you so much for attending. Thank you, Dr. Morshed, again for your presentation, and we hope to catch everybody tomorrow.
Thank you all for attending. Thank you, much appreciated.
Thank you.